This is the aptly named Toronto Tree Data Civic Hacknight talk. And I know I already introduced myself, but a little bit about me. So my name is Ethan Sansom. I lived in Saskatoon, Saskatchewan for basically up until now. I moved here for university in 2017, and I just graduated. And then I'm also a big fan of old chairs. For you Toronto people, I used to work at Morva on Queen Street, if anyone's been there. Professionally, I work full-time as a research assistant at the University of Toronto to a great economist, very smart, Eva Vaval. And we're studying universal basic income in the US right now, which is super interesting stuff. I also work as a data analyst for the Clean Air Partnership. They're here in Toronto. I think they have a tiny office like right behind City Hall. And then I also volunteer at Data for Good Toronto, which is super similar to Civic Tech. You should check it out. And about this talk, so a couple years back, I wrote an econometrics term paper about the relationship between Toronto's urban forest, geography, race, and income. And Luke asked me here, I don't know how you found that, but I was asked to present about that. So I'm going to do sort of a small walkthrough of that analysis while showing you about my favorite piece of data in the Toronto Open Data Portal, which is the street tree data set. And so the contents is why did I choose to look at tree data, why city trees are important, a few ways to look at the tree data. I'm going to do different plots that you might want to look at in just like the beginning exploratory analysis, and then some further work and studies, and like you can take this in your own direction. So yeah, I moved to Toronto, quick story, about a year and a half ago. School went online. I was actually studying at the University of Toronto Mississauga campus, and we moved here to the apartment. So I live in the Junction area, and this is a walk, this little Google Maps here, that I take pretty frequently. And so it's about 55 minutes. It's from High Park to the Eglinton West neighborhood. And I'm a census nerd. So like the first thing you do when you move somewhere is you look up all the census demographics about the place that you live. And in this case, I learned some really surprising stuff. So on this like 55-minute walk that I take, there's actually like a really fine gradient of income and sort of like racial demographics. So in this 55-minute walk, High Park, which has a median household income, according to the 2016 census, by the way, of 82,000, all the way up to a median income of about 60,000 just on this walk. And the visible minority population goes from about 19% to 42%. And it kind of begs the question, like, what does that look like when you walk from somewhere and the income goes down by 20,000 and the visible minority population goes up by 20%? Well, it looks like this.
For a moment, I want you to move the zoom.
Oh my God, that's all of
Sorry.
more. I actually don't know how to
you can just drag the thing. Yeah, just drag it.
There we go. And that. Alrighty. Yeah, but this is what this walk looks like. So I pulled two screenshots. These are just from Google Maps. And on the left here is 143 High Park Avenue, and that's in the High Park area. And then on the right is 188 Dunraven Drive. That's in Eglinton West. And you can sort of see the disparity in tree coverage, just like anecdotally on this walk. And it's a super common, phenomena. If you've ever been walking in Toronto in the summer, that you will go from one area to the next, and you will suddenly become very hot. And it's likely because there's a lack of tree coverage. And just to show you that I'm not cherry picking, this is the satellite imagery of both of those locations, about half a kilometer by half a kilometer. And you can see kind of obviously that High Park has a lot more tree coverage than Eglinton West, but population density and sort of the zoning is very similar. So it's not sort of an issue of like urban, residential versus other zoning types, which kind of begs the question, and so there's this disparity in trees that I noticed, but like, why do we care? Like, they're just trees. And trees are obviously super important, as a lot of people here seem to already know. But I'll tell you a couple of reasons. So if you're a money person, Toronto's tree canopy was evaluated in 2013 to be about $25 million in value just for carbon storage. And there's a whole bunch of other accounting over here. And a lot of economists love to look at housing evaluations and street trees. So having trees near your house is associated with just like aesthetic improvements. It generally raises the housing price. It also has environmental gains. So the trees will provide shade and windbreak, reducing heating and cooling costs. And then sort of pressingly, especially in Toronto, and especially given climate crisis and all of that, there's studies recently in Toronto, I think it was 2016, about street trees and heat-related deaths and ambulance calls. And there was like a staggering correlation between an area's street tree coverage and the amount of mortalities experienced by people walking on the streets for heat-related causes. So in short, we care about urban forestry because it's extremely important. And that kind of begs the question, just from that anecdote, does this extend to all of Toronto? So like, how does geography and income and race relate to how Toronto's urban forest is distributed? And luckily, the Toronto Open Data Portal has our back. So in this case, you can actually answer this question. Well, you can try to answer this question really easily. The first search you do is for neighborhood profile, and that gives you two data sets on the Toronto Open Data Portal. One is the 2016 census data, which is going to give us everything we need to know about race, income, and geography in Toronto. And the other is the street tree data set, which is a data set that describes the locations of every single street tree in the city of Toronto. And so we can take a look at that. That's the data set I'm going to show you, and we can look at it in a couple of different ways. So first, yeah, view. These are all of the street trees mapped out. Every single pixel on that graph is one street tree of about 660,000 in the data set. And then they're overlaid on top of the 140, as of 2016, neighborhoods in Toronto. I think it's 115 now. And so the data set tells us some cool stuff about those trees. So if you turn right from where I was on my walk, 143 High Park, you'll see this Japanese lilac that the tree data set tells us about. And there's other variables for the ID to identify the tree diameter, so 11 inches if you want to compare size or proxy age of trees, and then also the street name and the exact coordinates of the tree. And this is all well and good, but there's still some cleaning that needs to go into this data set before we kind of get what we want, because, I mean, this doesn't tell you anything about the relationship between income, race, and trees. Obviously, it's very coarse. So one thing to note in this data set is that there are huge areas with missing trees where I know there to be trees, and these are Toronto's parks. So kind of critical to this analysis is first understanding that. So you can see there's the Rouge National Urban Park, which is a massive dead spot of trees in Scarborough. It's also the Toronto Islands and High Park. And this kind of thing's important because if you want to talk about, urban tree coverage, you need to get a trees per square kilometer or some kind of tree density estimate. And if you just have these areas in the neighborhood, these are massive swaths of land that you say don't have any trees and are in fact parks, which will affect your analysis. If you're really keen, you'll see that the boundary files that are provided actually enclose a lot of water. So this Toronto Islands inset map here is just zoomed in to Toronto Island, and you can see the boundary in this neighborhood actually encloses all of the water. That is also an easy fix. So what I did for that is I used the census boundaries. They have a cartographic mapping file that excludes water area. And so with this done, we have a fairly reasonable way to approximate the street tree density in all of the neighborhoods in Toronto. And we can begin sort of trying to answer a question in better detail. So one classic super canonical way to do that is a heat map. And so this is the park adjusted street tree density by neighborhood in all 140 neighborhoods in Toronto. So in very bright yellow is areas with about 2,500 street trees per square kilometer, excluding area that is taken up by parks. And then in darker blue here are areas with about 1,000 street trees. I think the full range goes from about 500 to 2,700. And a little brief PSA here, because everyone should know about it. This color scale I'm using is the Viridis color scale. It's like super popular. If you're in like data science analytics, you've probably encountered it. But it's really high contrast. It's perceptually uniform, which means it groups like colors or like values with like colors, and far apart values are very distinct. And it is specifically designed for multiple forms of color blindness. So it's a great way to make your plots more accessible, just from day one. So now we can sort of get an intuition of like, was I lying? Am I crazy about what happened on my walk? And it turns out I'm not. So you can look at the Hyde Park Swansea area, and the tree density is about 2,500 compared to Eglinton West, where it's about 1,200. So what happens when you go from somewhere in Toronto with $80,000 in median income to 60,000 is that trees are cut in half, at least in this case. And one more thing that's really useful about this map is that you can sort of see the spatial relationships between how we distribute trees on a broad scale. And one really notable feature is that these map out the pre-amalgamation boundaries of Toronto really well, which a lot of like civic resource maps will tend to do this, sort of a worrying pattern, especially concerning Scarborough. But yeah, so these Toronto, Etobicoke, Scarborough, and the 3 Yorks are municipalities before Toronto merged into one city. So this Toronto is now Old Toronto. And you can sort of see that in the downtown area is where most of the city street trees are. And also really notably is that Scarborough is almost entirely made up of tree sparse areas. But I mean, that doesn't really help us get at the key question. We kind of need to go back to specifics. We want to answer relationships between street tree density and income. So we can turn to the classic scatter plot. So I have here tree density on the y-axis and median income on the x-axis, and then all neighborhoods are plotted out. So I also have a basic line of best fit there, and what this line of best fit suggests, that's the green line there, is that in Toronto, an increase of about $10,000 in median household income corresponds to about 72 more trees per square kilometer in a neighborhood. But like, you can hear the stats profs yelling at me, so there's like a lot of words of caution when you're doing this kind of analysis, especially with a line of best fit like this. I wouldn't advise it past exploration, but in this particular case, there's some reasons why we might be skeptical about this relationship between income and tree density. One, there's some very significant outliers. So Sunnybrook, for example, which I think is the richest neighborhood in all of Canada, but it's certainly in Toronto, it has a median household income of over 200,000, and it only has about 1,500 trees per square kilometer. Contrast that with Baby Point, which has a median income of 84K, lowest tree density in the entire city. So this might not be super convincing, but there is another relationship we're interested in, which is a little bit more stark and a little bit more convincing, despite the practical concerns of using a line of best fit. This is park adjusted street tree density versus the percentage of population which is not identified as a visible minority. That's a census definition. That's sort of what the question is asking. And you can see here that this line of best fit and the relationship between visible minority population and park adjusted street tree density implies that a 10 percentage point decrease in the portion of a neighborhood which identifies, or a 10 percentage point increase, sorry, that's a typo, in the proportion of a neighborhood which identifies as a visible minority corresponds to a loss of about 140 trees. So when you go from an area where it is, say, 60% not a visible minority to 40%, there's going to be a loss of about 280 trees per square kilometer, which is actually pretty significant. And also this relationship holds water, at least for further analysis, based on like the lack of outliers, and that it seems that it holds for most neighborhoods in Toronto. So as a start, this is a good sign that you might want to move on to further inquiry in this direction. And then I kind of want to finish this line off with an excerpt I really like from Inequality in Toronto discussion paper, which is a super dry title, but really interesting. And it talks about what a professor calls the 3 separate cities within the city when he's describing Toronto. And so he talks about an improving city based on already wealthy and gentrifying neighborhoods, a stable city, and a declining city in the outer suburbs of Toronto, which is like a really common pattern here. And people in like spatial analysis often talk about polarization, like geographically in Toronto. It's like a really pervasive issue here. But I want to propose a thought experiment about this, which is what if we actually divided Toronto into 3 cities, and those cities are based on how many trees you have. And so here We have Toronto, one of the three. This is the least third tree dense neighborhoods in Toronto. And you can see that it contains a lot of Etobicoke, some of North York, and basically all of Scarborough. So who lives in the least tree dense city? The median household income in this entire region is about $60,000, and 65% of the population identifies as a visible minority, and the poverty rate is 22%. When we go to the middle, so that's between 1/3 and 2/3 most tree dense. You can see that this is sort of everything surrounding the center of Toronto and that outer region there. And the median income goes up by a little bit. The percent visible minority decreases a little bit, and the poverty rate goes down a tiny bit. And then finally, when you get to Toronto 3 out of 3, this is that intersection of the city that we keep seeing again and again with the most third trees. And suddenly household income goes up by about $10,000 to $70,000. There are only 34% of people who identify as a visible minority here, which is wildly below the Toronto average and all the other areas. And the poverty rate has fallen to 17%. And so when you look at those three things together, you sort of see a clear pattern. And I don't mean to say that trees necessarily define this pattern, but I do mean to say that there are three very distinct Torontos, and you can sort of look at the way resources have been distributed and see just how stark the differences between these areas. And urban forestry is just one part of that. And then some additional reading on this topic that I would highly recommend in the future. So there's a U of T PhD student. She's a PhD student when I was making this paper, so she's probably a PhD now, but Jacqueline Scott in Toronto studies the intersection of race, specifically Black history, and forestry access and environmental discourse. And it is really interesting stuff. And obviously, like each sort of group's experience with urban forestry is very distinct. So I don't want anyone to take it away that if you're a visible minority or a not visible minority, that completely defines how trees are allocated in the city, because it's a simplification. And Jacqueline's work is just one part of that. Super interesting. And then there's also a 2017 paper from Ryerson that goes into way more depth, but basically finds conclusions along these lines, especially these sort of agglomerations of wealthier areas in the downtown. And it's related to trees. And there's some really interesting stats if you're into that sort of thing. And yeah, that's Toronto tree data. I hope you enjoyed.
All right, so we'll be starting the Q&A session. So if you're online and if you want to ask a question, drop a Q in the chat and we'll go by the order of the Qs. In the meantime, does anyone here have a question? Okay, so